Hi everyone, I would like to welcome you in this series of lecture about hyperspectral imaging and its application in agri-food quality evaluation. At the beginning, I would like to introduce myself. My name is Gamal ElMasry. I'm coming from Suez Canal University in Egypt, and recently I'm working in National Research Food Institute, INRA, in France. And we prepared a series of literature using how to use the spectral imaging technology for quality evaluation of agri-food products. This presentation will be divided to 4 segments. First of all, we will introduce introduction about the hyperspectral imaging system. And second, we will differentiate between hyperspectral imaging and multispectral imaging and how the configuration and the image acquisition moves between both systems. And we will shed some light about using one of the most important technologies called illumination-based multispectral imaging. And finally, we will present one case study of using multispectral imaging for seed monitoring. With first session, I will give you some introductory statements and introductory information about spectral imaging in general. To evaluate our product, first of all, we need to use all of our senses. We need to smell the product, we need to taste, to evaluate the appearance, the gels, the texture. If we use all of our senses, we can, as you see here, if we are a consumer, we should feel happy, healthy, and if you are a trader, you can earn a lot of money for selling high-quality product, and also you can share your product in national and international markets. Unfortunately, it is not ideal solution all the time, but due to invasion of microbes and microorganisms, your product could be invaded by microbes and microorganisms coming from animals, from air, from hands, from insects, whatever. And of course, all of these parameters can affect the overall quality of the product. And if you are a trader, of course, you will lose your share in international markets and the national market. And if you are a consumer and you start to consume this bad quality, you can get sick and you can go to the doctor, and finally your condition will be very severe. So how we can evaluate the quality of the product? There are 2 methods. First method is to use ordinary method. Ordinary method, the people usually, or the workers usually stand up along the conveyor belt and they start to pick up some rotten or diseased or damaged product away from the conveyor belt in the production systems. And unfortunately, all of this system is manual, slow, subjective, tedious, and of course is not sufficient for market demand. Other solution is to install robots or cameras using a vision system, depending on the color imaging system. This system as well is not even sufficient in some situation, like objects with similar colors, or in case of complex classification, like very tiny, very small objects like seeds. Even if you need to try to predict some internal attributes like chemical composition, this vision or normal imaging system is not sufficient to do that. And in general, if you need to see something not visible to your naked eyes, the normal camera is unable to give you this kind of information. So what is the solution? The solution is to find a technology that can fulfill a lot of parameters, a lot of characters. Like it should be non-destructive, rapid, consistent, reliable, and give you some information for internal quality parameters, and should be overall non-contact and automatic technique. All of these parameters could be found in spectral imaging. So what is the spectral imaging? Why we choose this one? Because it is a non-destructive technique and very fast, and can give you a lot of measurements simultaneously at the same time. So imagine, for traditional method, if you have this piece of very nice fish, so if you need to get information about the quality, overall quality of this fish, so you need to take this fish to the lab, to cut, to mince, and then go to your ordinary instrumental measurement using a wet chemistry method to have overall one value of average chemical composition. On the other hand, if you need to implement the spectral imaging, you have the same piece of food, and then with the remote imaging system like spectral imaging, you can acquire one image, and from this one image you are not going to obtain the overall quality, the overall average for the whole sample, but you can obtain the value of chemical composition for each single spot in your sample, and then finally you can find a very nice distribution of any chemical composition of the sample. So if you need to tell, we have some impression about the sample that is already liable to cut and mince. Of course, it is not happy to do that, but the sample here should be happy because nobody touched it to find the internal chemical composition. In the second session, we are going to speak about the hyperspectral imaging and the multispectral imaging and the configuration for both systems, and we see you in the second shot.